Good morning, all of you. Now we are discussing the second lesson, P block element 1. So the last class we discussed about the carbon monoxide, some of the reactions and about the uses. Today we can discuss about the carbon dioxide. We know that one, what is the formula of carbon dioxide and the production of carbon dioxide properties, some of the chemical properties, and also having structure of carbon dioxide, same like that the carbon monoxide, and uses of carbon dioxide. And one of the topic, silicon tetrachloride. Tetra means 4. So silicon is surrounded by 4 chlorine atom and their properties, some of the chemical reactions, uses. And one more, a small topic, a very important question. Silicones. What are silicones? Silicones, other name is about that polysiloxane. What are silicones? Silicones are the organosilicon polymers. One of the very important question. And their preparation. Okay. We can discuss one by one. Carbon dioxide. We know that the formula of carbon dioxide is CO2. Please all of you take the note. One by one we can discuss. Carbon dioxide occur in nature in free state as well as in the combined state. Carbon dioxide occur in nature, it is nature, and free state and as well as in the combined state. The constituent of air in carbon dioxide is 0.03%. It occurs, that is carbon dioxide occurs in rocks as calcium carbonate and magnesium carbonate. All of you know that one, calcium carbonate, CaCO3, and magnesium carbonate, MgCO3. Preparation of carbon dioxide. That is about the carbon dioxide is prepared by the burning of coke. Coke means carbon in excess of air. Burning of coke, that is carbon plus O2 gives carbon dioxide. You have to write the delta H, that is enthalpy. Enthalpy is equal to minus of 394 kilojoules mole inverse. Okay. Next one is about that calcination. What is about the calcination? Already we learned it, calcination. That is, it is one of the process. Calcination is one of the process in which the concentrated ore is strongly heated in the absence of air. Okay, that's a process. The concentrated ore is strongly heated in the absence of air. I am taking one of the ore is called calcite. Calcite means calcium carbonate. Calcium carbonate, CaCO3. The calcium carbonate on strongly heated we get calcium combines with oxygen, calcium oxide, and also carbon dioxide gas. This is one of the method. Carbon dioxide is prepared by the reaction between calcium carbonate and also dilute hydrochloric acid. What is the formula of calcium carbonate? CaCO3 plus hydrochloric acid means HCl gives calcium combines with the chlorine we get calcium chloride, and also hydrogen combines with the oxygen we get water molecules, and also we get carbon dioxide. This is another method. The equation is balanced. Next about what are the properties of carbon dioxide? It is a colorless. All of you know that one. It is a colorless and non-flammable gas. Am I right? It is a colorless and also non-flammable gas. It is heavier than air. Okay. What is about the critical temperature of carbon dioxide is about 31 degrees Celsius, and also carbon dioxide is readily liquefied. Am I right? Readily liquefied. Next one. Carbon dioxide is one of the very stable compound. Okay, one of the very stable compound. Even at 3100 Kelvin, only carbon, that is 76% decomposed to carbon monoxide. That is, carbon dioxide is converted into carbon monoxide and oxygen. That means at high temperature, we are applying by the reaction, we are taking some carbon dioxide and giving a high temperature, 3100 Kelvin. At 76% of carbon dioxide is converted into carbon monoxide and also oxygen. Am I right? And remaining at still higher temperature, it decomposes into carbon and oxygen. How to write the equation? Carbon dioxide on heating at 3100 Kelvin, we get carbon monoxide plus, and also we get oxygen. How can you balance the equation? The reactant side having 2 oxygen, the product side also having 3 oxygen. So the product side we can be written as half O2. Half O2 means where I consider as a 1 oxygen atom. Okay, 1 oxygen atom. So 1 plus 1 we get 2. Am I right? Next about the carbon dioxide at high temperature we get carbon plus oxygen. Okay. Next about that, the oxidizing behavior. Oxidizing behavior is one of the important questions. These are some important area you have to thorough it. Oxidizing behavior. At elevated temperature, carbon dioxide acts as a strong oxidizing agent. Carbon dioxide acts as a strong oxidizing agent. At elevated temperature means we can be taken as at a higher temperature. Okay, higher temperature, carbon dioxide reacts with magnesium. Here what is happening here means this magnesium combines with oxygen, we get magnesium oxide, and carbon combines with oxygen, we get magnesium combines with oxygen, we get magnesium oxide, and also carbon is leaving out. Am I right? So which are the products are possible here? Magnesium oxide and also we get carbon. This is one of the reaction. We have to balance the equation. How much oxygen is there in the reactant side? 2 oxygen. The product side also make it 2. So we get 2 MgO. Am I right? So the reactants are also we can be changed it to magnesium. One of the important question. Next about one of the PTA question, Parents Teachers Association question. One of the question, water gas equilibrium. Water gas equilibrium, very very important question. What is about the water gas equilibrium? That is carbon dioxide. There is a reaction between carbon dioxide and hydrogen. We get carbon monoxide and also water molecules, water H2O. Here this reaction, hydrogen combines with one of the oxygen, we get water molecule. Hydrogen combines with one of the oxygen, we get water molecule, and also we get carbon monoxide. Carbon monoxide plus water means it's about that water gas. Next about the acidic behavior. One of an acidic behavior. That means carbon dioxide reacts with water. Here carbon dioxide is one of an acidic in nature, one of the small and acidic in nature. This reacts with the water to form carbonic acid. What is the formula of carbonic acid? H2CO3. That is this oxygen combines with the CO2 to form H2. Am I right? H2CO3. Here this carbonic acid undergoes a dissociation to form H++, H3O, HCO3 minus, HCO3 minus. So you have to write the equation. CO2 plus H2O gives H2CO3 gives dissociation, that is H++ H3O, HCO3 minus. Next about the structure of carbon dioxide. Yesterday we learned about the structure of carbon monoxide. Now we are learning the structure of carbon dioxide. Carbon oxidation state is +4. Don't forget, that's one of the important question. Carbon dioxide, what is the oxidation state of carbon? That is a +4 oxidation state. Carbon dioxide also having the linear shape, that is about the linear structure. Carbon monoxide is also have a linear structure, am I right? With equal bond distance for carbon and oxygen bond. In this carbon dioxide molecule, there is a 2CO sigma bond. Okay, 2CO sigma bond, and also in addition to 3 center 4 electron bond. 3 center means 1 oxygen, 1 carbon, 1 oxygen. Am I right? Carbon dioxide can be written as oxygen, carbon, oxygen. Am I right? So here having 1 bond means here make it 3 bond. Okay, so how much center is there? Oxygen is 1 center. Next carbon is 2nd center. Next oxygen is 3rd center. So how much center is there? 3 center, 3 center, how much electron bond having? 1 bond, 2 bond, 3 bond. So we are saying 1, 2, 3, 4. 4 electron bond. Okay. By covering all the 3 atoms. All the 3 atoms means oxygen, carbon, oxygen. Am I right? So we have to write the equation. We have to write the formula of carbon dioxide. What is the formula of carbon dioxide? CO2. Already we learned Taravit. Okay. That is about, already I told you that carbon, they are having the single bond. Oxygen having single bond. Carbon, oxygen, single bond is you have to give the 6 electron. Okay. And then carbon and the other oxygen having 3 bond. Am I right? 3 bond. That means carbon valence is 4. One having minus and another having plus. Am I right? Next one. This electron when attached here means, so what happened here? Here it is converted into 4 electrons. First oxygen it converted into 4 electrons. Here this bond, the triple bond is coming outside. Am I right? So here having 4 electrons. This oxygen having 4 electrons. So the both the two side oxygen having 4 electrons. There is no charge. Okay, charge we can be find out. Next step, what happened is again. Here what is happening here means one of the, here this oxygen bond is goes to here. So again this double bond is converted into triple bond. So this bond is converted into electrons like that coming out. So the last oxygen is having 6 electron. Am I right? So this is having a negative charge and first oxygen is having plus charge. Next, how can you find the charge? First molecule, that is the first carbon dioxide molecule. You have to find out what is yesterday I told you about that. What is the formula? Valence electron minus lone pair minus bond pair divided by 2. That's a formula for finding the each element charge. Okay. This is not for the molecular formula. This is not a molecules formula. Here having the each element formula. Each element means oxygen having this formula. When you are finding the charge of oxygen means you can be use this formula. When you have find the carbon charge means you have to use this formula. Next oxygen also you have to find this formula. Okay. So I am using this formula. Valence electron minus lone pair minus bond pair divided by 2. So first one oxygen, how much valence electron? All of you know that one. Atomic number of oxygen is equal to how much? What is the atomic number of oxygen? Oxygen is equal to 8, am I right? First shell we can be accommodate 2 electrons. Second shell we can be accommodate how much electron? 6 electrons. So the valence electron is 6. Next, lone pair of electrons. This oxygen is surrounded by how much electrons? 1, 2, 3, 4, 5, 6. So we have to write 6. That's about the lone pair of electron minus. Next, about the bond pair. Here in between carbon and oxygen, how much bond is there? 1 bond. 1 bond is how much electron? 2 electrons. So we have to write 2 by 2. Am I right? So we can written as 6 minus 6 is 6 minus 6 minus 2 by 2. This can be written as 6 minus 6 minus 1. That is 2 divided by 2 is equal to 1. 6 minus 6 is equal to 0. We get minus 1. So we are writing the minus charge here for first oxygen atom. Okay. Next goes to the second oxygen atom. What is the valence electron for oxygen? Is 6 minus how much lone pair of electron here? 2. Am I right? That is lone pair of electron is 2 minus how much bond pair they are having? Bond pair means 3. 3 means we can write 6 by 2. Okay, 1 bond pair means we need 2 electrons. 6. There is 3 bond pair means 6 electron. Am I right? So 6 by 2. So how can you write 6 minus 2 minus 3? Am I right? So 6 minus 2 is equal to 4. 4 minus 3 is equal to plus 1. Am I right? So the charge is plus. Here, second one. You can find the second molecule carbon dioxide. First oxygen, valence electron, all of you know that one. 6. 6 minus, how much lone pair of electron? 4 minus, how much bond pair? 2 bond pair. 2 bond pair means 4 electron. 4 divided by 2. Am I right? 6 minus 4 is equal to 2. 2, that is 4 minus 4 by 2 is equal to 2. So we can be written as 2 minus 2 is equal to 0. So the first one oxygen is having no charge, 0 charge. Am I right? That is a neutral, no charge. We can write the no charge. Next about that, Next oxygen atom. Oxygen atom valence electron is 6. Am I right? Valence electron 6. A lone pair of electron. How much lone pair of electron they are having? 4. Am I right? 4 electrons having 2 pair of electron. It is 4 minus bond pair. How much bond pair they are having? 2 bond pair. 2 bond pair can be written as 4 by 2. So 6 minus 4 is equal to 2. 4 by 2 is equal to 2. So 2 minus 2 is equal to 0. Am I right? So here also 0, there are 0. So this compound having no charge. What about the last one? Oxygen. Here oxygen, what is the valence electron? 6. Next about number of lone pair. How much lone pair of electrons having this oxygen? 2. 2 minus. Next about here having 3 bond pair. We have to write 6 by 2. Am I right? So 6 minus 2 is equal to 4. 4 minus 3. That is equal to 4 minus 3 is equal to plus 1. So the charge is plus. The last one oxygen. What is the valence electron? Valence electron is 6. Here how much lone pair of electron having? 1, 2, 3, 4, 5, 6, 6. So what is about the bond pair? One having 1 bond pair means 2 electrons. There is 2 by 2. So 6 by 6, 6 minus 6 is equal to 0 minus 1. So what is the answer? Minus 1 is the answer. Am I right? Next about the uses of carbon dioxide. What are the uses of carbon dioxide? I think that about 4 uses we have. Try to learn at least 3 uses thoroughly. Carbon monoxide is one of the use means it produces an inert atmosphere for the chemical processing. Okay, chemical reaction. Some of the chemical reaction, that means we are using for the inert gas configuration. That is inert gas we are taking means that we are inert gas temperature we are using means by the reaction between carbon dioxide. It's very useful to carbon dioxide is used to produce an inert atmosphere for chemical reaction, chemical processing. Okay. Second one about that photosynthesis. For the photosynthesis, carbon dioxide is a very important. Okay, very important for the photosynthesis. It's about the biological process. Next about it is used as a fire extinguisher. Am I right? And also it is used as a propellant gas. Propellant means we know that one the substance which promote the motion. Okay, by using the propellant. Okay. Next about that, it is used, carbon dioxide is used for the and some of the soda bottle. I mean, some soda bottle also we are using carbon. That is about the carbonated beverage. That is that means soft drinks we are using like that in the production in the form. Okay. These are the some of the uses. Next about we can be discussed about the one of the very important questions. The very important question. Silicon tetrachloride. Silicon tetrachloride. What is the formula of silicon tetrachloride? That is SiCl4. That is which are the element present means one of the silicon, and there the silicon is surrounded by 4 chlorine atom. 4 chlorine atom. Okay, this is one of the important. Silicon tetrachloride. What is the use? What is the applications of silicon? Silicon, all of you know that one. The silicon is used as the semiconductor. Am I right? Semiconductor device. Some of the device they are using silicon. Okay. One of the main important chemistry also we are using. What are the purpose? What are the uses of silicon tetrachloride means? In the synthesis of silica gel, silicic ester. That is silicon compounds. We are using some of the silicon compounds for preparing the ceramic materials. That are the all uses is from silicon product. Okay. Anyhow, how can we write the preparation of silicon tetrachloride? The silicon tetrachloride can be prepared by the reaction between silica. What is the formula of silica? SiO2. SiO2 means all of you know that one is a sand. Am I right? Sand, silica. The sand that is silicon reacts with the carbon in the presence of chlorine, and we are heating at the temperature is about 1675 Kelvin. 1675 Kelvin. It's a very important. Don't forget the temperature. SiO2 and reacts with the carbon in the presence of Cl2 we get silicon combines with chlorine we get silica tetrachloride, and carbon combines with the oxygen we get carbon monoxide. Silicon reacts with the carbon in the presence and also in the presence of chlorine we get the temperature 1673 Kelvin, we get silica tetrachloride and also carbon monoxide. We have to balance the reaction. How much chlorine is there? In the product side 4 chlorine, so make it 2 into 2 Cl2. Like that, chlorine is balanced. What about the oxygen? Here having 2 oxygen, so the product side also make it 2 oxygen. So 2 carbon. Now the equation is balanced. And one more important question. Silicon reacts with hydrochloric acid, we get silica tetrachloride. That means the silicon combines with the chlorine. HCl means HCl having chlorine. Silicon reacts with the Cl, we get SiCl4 and also H2 gas. How can you balance the equation? How much chlorine is there? 4 chlorine. So if you are making 4 means how much hydrogen is there? 4 hydrogen. So make it 2. Now the equation is balanced. Next about what are the properties of silicon tetrachloride. Silicon tetrachloride is a colorless fuming liquids. One of the colorless fuming liquid, and it is about the freezes at minus 70 degrees Celsius. Very important point. Try to underline that one. In the moist air, silicon tetrachloride can be hydrolyzed with water. Hydrolyzed water, we get silica and also hydrochloric acid. Okay, silica and also hydrochloric acid, and reaction between SiCl4. How will you write the silica tetrachloride formula? SiCl4. Am I right? This one reacts with the water. What is the formula for water? H2O. This hydrogen combines with the Cl to form HCl, and Si and combines with the oxygen to form SiO2. So 2 chlorine is there. Sorry, 4 chlorine is there. So make it product side also 4 chlorine. About that silica having SiO2, 2 oxygen, the product side we have to change the reactant side also 2. Next, when silica tetrachloride is hydrolyzed with moist air, we get a linear perchlorosiloxane. Linear perchlorosiloxane product is obtained. How to write the equation? How to start with the Cl, one of the bond, SiCl2O, N times SiCl3. Cl bond SiCl2O, N times SiCl3, where N is equal to 1, 2, 6. Here having N times, the N may be changed as 1, 2, 6. Next reaction between silica tetrachloride and reacts with ethyl alcohol. What is the formula of ethyl alcohol? C2H5OH. Am I right? Silica tetrachloride and reacts with ethyl alcohol. Formula is C2H5OH. We get SiO C2H5 4 times. SiO C2H5 4 times. What's the name of the compound? 4 means tetra ethoxysilane. What's the name of the compound? Tetra means 4 ethoxysilane. And also we get hydrogen combines with the chlorine, we get hydrochloric acid. How much chlorine is there? 4 chlorine. So the product side also make it 4 there. Okay, so how much hydrogen is there? 4. So the reactant side methyl alcohol also make it 4. Now the ethyl also having 4. The equation is balanced. Next one, silica tetrachloride and reacts with ammonia. Ammonia means all of you know the formula NH3, and the temperature. What is the temperature here? We are applying means 330 Kelvin. In the presence of ether, okay, union ether we are taking, we get one of the product called chlorosiloxane. chlorosiloxane. What is the formula? Cl3 SiNH SiCl3. Once again, Cl3 SiNH SiCl3. That means chlorosiloxane and hydrogen combines with the chlorine, we get hydrochloric acid. Here we have to balance the equation. Here having 3 chlorine, here also having 3 chlorine, and high Cl also chlorine, am I right? So if you are making the product side 2 high Cl, if you are making, means how much total chlorine is there? 3 plus 3, 3 plus 3 plus 3 plus 2. So we get 8 chlorine. So make it 2 in the reactant side. 2. So 2 into 4 is 8. Chlorine is balanced. And what about the silicon? Silica here having 2. So here also having 2. That also balanced. What about the nitrogen? Having 1 balance. What about the hydrogen? Hydrogen 3. Okay, hydrogen also balanced. Here how the reaction is going on means, here nitrogen having 3 hydrogen. Here 2 hydrogen combines with the 2 chlorine. 2 hydrogen combines with the 2 chlorine. We get 2 high Cl is leaving. So you have to write the remaining product. That is Cl3 SiNH SiCl3. Then what are the uses? What are the uses of silicon tetrachloride? Silicon tetrachloride is used in the production of semi-conducting silicon. Semi-conducting silicon. It is used in the production of semi-conducting silicon. And also, silicon tetrachloride is used as the starting material in the synthesis of silica gel. Silica gel, we are using some silica gel for some of the medicine like that. Silica gel we are using. And also, silicic ester. Ester for what purpose? Means to bind. That is binder we are saying. Bind for the ceramic materials. Okay, some of the vessels we are making from ceramics. Okay, ceramic materials, for that we are using silica. Okay. The next is about that silicones. Here the silicones preparations are very important question. Okay, silicones are very important question. What are silicones? About that we can be discussed. Silicones are polysiloxane and are one of an organosilicon polymer. One of an silicon. What is about that? It is one of the silicones are the organosilicon polymer. They have the general formula. What is the general formula? Means R2SiO. R2SiO. R2 means one of an alkyl. Dialkyl. R2 means one of an dialkyl. SiO. Siloxane. SiO. Okay. So silicones are polysiloxane or organosilicon polymer. They have the general formula R2SiO. The general formula is similar to that of ketone. That is R2SiO. R2SiO. That is similar to ketone R2CO. So they were named as silicones. The silicones may be linear shaped or cross-linked shape. Okay. They have very high thermal stability. So they are called as high temperature polymers. Silicones are called as high temperature polymers. We can write the preparation of silicones. That is, silicones is prepared by the hydrolysis of dialkyl dichlorosilane. Dialkyl dichlorosilane. Otherwise, we can be write diaryl dichlorosilane. What is the general formula? Means Ar2SiCl2 for diaryl. Diaryl, that is Ar2SiCl2. Diaryl dichlorosilane. Another one formula, dialkyl dichlorosilane, that is R2SiCl2. That is, we have to write one equation. RCl plus silica Si gives the presence of copper at temperature 570 Kelvin. RCl plus Si, RCl, R means we can be take one of an alkyl group. For example, methyl chloride, we can be used as one of the methyl chloride also, CH3Cl like that, okay. RCl plus Si gives R2SiCl2. What's the product is obtained here? R2SiCl2. What is about the R2SiCl2? Dialkyl dichlorosilane. Dialkyl dichlorosilane. So the product said how much R is there? 2R. So the reactants will also make it 2R. Okay. So we are preparing by passing the vapor of RCl or ARCl, alkyl chloride, or we can be taken as aryl chloride. The silicon at the temperature is about 573 Kelvin. With the copper as a catalyst, we get dialkyl dichlorosilane. Here the dialkyl dichlorosilane yield gives a straight chain polymer. Which polymer? One of the straight chain polymer with grow from the both sides of this group. We get one of the straight chain polymer. What is a straight chain polymer? We can be discussed. First you have to write the formula. R2SiCl2. R2SiCl2 can be written as, center you have to write silicon, Si. How much R is there? 2R. So above 1 R, below 1 R. So R2 is over. How much chlorine is there? 2 chlorine. Cl. Now 2 chlorine is over. On reacts with water. We are taking water. Here it can be read H2OH. Suppose we are adding H2OH. Here also we are adding H2OH. So this hydrogen combines with the chlorine, we get HCl. And the OH is attached there. Here also hydrogen combines the OH, hydrogen combines the Cl to form HCl. The OH is attached. Am I right? So what is the formula here? Si OH OH R R. Si OH OH R R plus how much HCl? Plus 2 HCl. This is one of the reaction. Next, I told that R2SiCl2, that is a dialkyl dichlorosilane, on reacting another one compound, dialkyl dichlorosilane. Am I right? We get one of the straight chain polymer. Am I right? Here we are removing the Cl by adding OH. We are removing the Cl by adding OH. We get one of the compound Si R R OH OH. Am I right? Again I am taking one more compound Si R R OH OH. Here one of the hydrogen combines with the OH. One of the hydrogen combines with the OH. We get water molecule. Am I right? We get water molecules. What's the remaining product here? Remaining organic compound, one of the compound. OH, Si, above R, below R, join with oxygen, again with the silicon, R, ROH. This here the area, this area water is removed. Am I right? So this is the next product. Again I am adding Si, R2, Si, OH twice I am adding. Here which is I am adding here? R2, Si, OH twice. This compound I am adding, again adding. This can be written as Si, R, R, OH, OH. This compound, one of the hydrogen combines with this compound, one of an OH to form water molecules. Am I right? Here one of the hydrogen, here one of the OH to form water molecules. What's the remaining product? This group will be attached here. So what's the remaining product? OH, Si, R, R, O, Si, R, R, O, Si, R, R, OH. This we are saying a straight chain polymer. The compound is increasing. The chain is increasing. Am I right? Okay, the chain is increasing. So we are saying straight chain polymer and etc. Okay. Then again we are adding one more compound we get. Again we are adding one more compound, and again we are adding means we get more compounds. Am I right? Next, the hydrolysis of monoalkyl chlorosilate. What is the formula for monoalkyl? Mono means one. R means alkyl. Mono means one. Am I right? So one of an alkyl, that is 1R. Am I right? RSiCl3 gives a very close, very complex cross-linked polymer. One of the cross-linked polymer. Here, we are learning now linear silicone. These linear silicones are converted into cyclic silicone. Otherwise, we can be say as a ring silicone. Now we are writing the linear silicone. This linear silicone can be converted into cyclic silicone. Otherwise, we can be say ring silicone. Okay. When water molecule is removed, water molecules are removing. I am writing one of the compound. For example, SiO(Si). Si means silicon, oxygen, silicon. Below also, here having silicon, oxygen, silicon. Then join in oxygen. Here also, silicon already having silicon, oxygen, silicon. The four sides I am giving one of the alkyl group. That is about the methyl group. Alkyl group is methyl group. Okay. Me. How much Me I wrote here? 1, 2, 3, 4, 5, 6, 7, 8. Okay. So what is happening here means I am just changing the shape of this molecule. Okay, I am taking this oxygen and the above, and also this silicones come to like that below. I am adjusting such a way like that here. So what is the product I am starting here? Just like one of the ring shape. It possesses one of the ring shape. That I am starting with oxygen, Si, oxygen, Si, oxygen, Si. Am I right? Start with this oxygen. Okay, in the reactant side, this oxygen I am start with here. Oxygen, Si, oxygen, Si, oxygen, Si. Am I right? Join in there. Each silicon have how much methyl group? 2 methyl group. Before also that also having 2 methyl group. Each silicon having 2 methyl group, 2 methyl group, 2 methyl group. Am I right? Then we get what is our product means. One of the product, that is I am starting. The methyl group is changed into R. So what is the product here? R, SiO, 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 like that increasing. Am I right? From top to bottom we are writing means O, SiO, SiO, like that is going on. Am I right? So the below also you have to write SiO, SiO, SiO. Each silicon is joined with oxygen. Am I right? Here each silicon is joined with oxygen, and the ends are surrounded by alkyl group. Am I right? Ends are surrounded by alkyl group. This is about the silicons, but these are not an important area. The important area is about that what are the types of silicon. The types of silicons means we have many types having. For example, linear silicon, cyclic silicon, cross-linked silicon. These are some of the important area questions. And about we have to learn about the silicates. What are about the silicates? Silicates means we have to learn about that the minerals which contain silicon and oxygen. That we are saying about the silicon. That is our tetrahedral units linked together by different pattern arrangement. Different pattern arrangement are called as silicates. Okay, let us we can discuss later. Then what are the types of silicate means? That is about the orthosilicate, pyrosilicate, cyclic silicate, silicates, chain silicate, double chain silicate, and about the 3-dimensional silicate. These are all having. So one by one we can be discuss. Okay, discuss later. Anyhow, today our assignment is about that. About that first question. Draw the structure of carbon dioxide. Draw the structure of carbon dioxide. What are the uses of carbon dioxide? What are the uses of silicon tetrachloride? Uses of silicon tetrachloride. Write about water gas equilibrium. Water gas equilibrium. Write about water gas equilibrium. And write any one preparation of silicon tetrachloride. Write any one preparation of two preparation having. Write any one preparation of silicon tetrachloride. Thank you all of you. Thank you. Have a nice day.